There we go. Hello Internet, I am Michael. Welcome to my first live coding stream. I'm not really used to this, so excuse the bumps. I am developing a game engine, and I've been kind of doing it in the vacuum of my own head for a while, and I thought it would be a nice change of pace to start sharing it. So I decided to start up live streaming. We'll see how it goes, see whether I still want to do it after doing a couple of these. But yeah, the gist is that I am working on a game engine. I called it Enterprise. And I'm kind of getting close to the point of being able to do cool stuff with it. So I wanted to kind of just focus myself, start streaming while I do it. And if anybody pops in and wants to give some advice, that'd be cool. A little bit background of my knowledge, skill set, and capabilities. I'm entirely a self-taught programmer. I'm very good at C++ for the most part, and a handful of other languages. This game engine is going to be developed in C++ 17. I don't really have any interest in setting up any scripting languages for it. I know that like a lot of game engines find it really popular to set up scripting through things like C# or whatever. But this one's pretty much just going to be straight C++. And yeah, that's it. I'm kind of somewhere between a expert and a hobbyist. Like I'm not blind to a lot of topics, and I kind of have a good idea of high level and low level C++ stuff, and game engine and technology stuff in general. But at the same time, I wasn't trained at a formal institution, so there's a lot of computer sciencey topics that I just either am unaware of, or I just kind of don't have as much place as much importance on as other people do. So yeah, basically, might as well just get started. I'm not really interested in taking time on these streams to provide an overview of the engine. I don't think. I think that's a big ask. And eventually, when I get the engine closer to being finished, I'll be doing a much better job at that. I'll probably make like a little YouTube series or something. But to provide just the briefest of overviews, basically, Enterprise is like a modular framework more than it is an engine. So by that I mean that when you're developing a game in Enterprise, first, you're always going to need to program in C++. And that's not just because I don't like scripting languages. That's because I think a lot of game engines kind of have stepped away from didn't mean to click on that. A lot of game engines have stepped away from doing programming as the primary game development tool. Like if you use Unity or you use Unreal Engine, you can do an entire game in the editor without any programming, technically. I mean, it's if you want to get really, really technical, then yeah, you got visual scripting, which is a kind of programming. It's called visual programming. But it's kind of a data-oriented approach where you make scenes, scene files, and then you put behaviors like scripts on entities in those scenes, and then those scripts handle the behavior of the game. And that can lead to some weird circular thinking about the way that you do programming. So like, for example, when you're building a game in Unity or whatever, you'll oftentimes have to do like a singleton pattern game manager. So like, just to track the game rules, you would have in every scene a script that would start up, like you put it on like an empty object in the scene, and then it would check to see whether an instance of itself is already in existence, and then create itself if it's not. And so you're kind of dependent upon having that empty object in every scene in order to make sure that the game runs every time you open up a scene. And yeah, and it's, you know, it can lead to some kinds of weird things that people have gotten used to, but I think they're still weird. So this game engine kind of builds upon the idea that you're going to be compiling your game in a compiler like Xcode or Visual Studio. And it does not depend upon scene files for the organization of how the game works from start to finish. Anyway, the gist of this engine is that when you're developing a game, you're going to be making game states or ECS systems. And those drive the behavior. So you'll start up your game, you'll have a game state that actually defines your game rules. And if anybody's ever worked in like XNA, for example, you might be familiar with like how you have like the entry point to your game, and I'm going to actually pull that up in this one. If I go to I have a simple sandbox project going on, sandbox.cpp. Like this function is like the entry point to your game, and all I'm doing here is that I've got a function that assigns controllers that you plug in. So like if I've got an Xbox controller here and I connect it, it just takes and says, okay, we're going to use that controller now, and then it pushes this. It says I have a state manager push state, scene manager dev state, and that's just a state in which I'm currently testing things out. But basically, you would just go from state to state to state. Like you'd have like a main menu state, and then a loading screen state, and then your gameplay state, and then so on and so forth. And that's the first way that you can develop your game. And the second would be with ECS, and that's something that I'm going to be dealing with today. ECS it stands for Entity Component System. System in there is actually part of the system. It's not saying that this is a system about entities and components. The idea is that when you're developing a game, the things in your scene or in your game world will be basically just like empty bags, kind of like you see in Unity, where you place an entity and then it doesn't do anything yet, until you add components, and components are the things that define the behavior. Where that's a little bit different from what I think most intro devs are used to in game engines like Unity, is that the behavior is actually not in the component, it's just defined by. Instead, what you'll do is you'll have an entity, which is just like I don't know, like an ID and maybe some pointers and administrative things to help manage the lifetime of the entity. And then you'll have the components that are just bags of data. So, for example, if I wanted to add a static mesh component to a entity, the static mesh component will only contain things relative to making the thing happen. So it'll only contain things like a path to the mesh, import settings for that mesh, whether it's going to be dynamic or not. It's LOD stuff. Just the numbers that define that. And then separate from the component data, there's going to be just a single system somewhere that manages all the data for all of those components at once. So you have entities, components, and systems. My global ECS system is going to be called SceneManager. That's I might change that idea down the road, but right now I'm calling it SceneManager, and I don't see a reason to change it. And basically, I'm trying to get it set up in such a way that all of the run-of-the-mill stuff is handled by SceneManager. So things like creating entities and serializing entities and things like that, that's all taken care of for you. But a game developer who wants to build in Enterprise, they can easily create a new system, like a system, like a mesh system or an animation system or some other gameplay system that can plug into the SceneManager and become one of those ECS systems. And then, additionally, they can define new kinds of components. And then those become serializable and part of your scene files or whatever. So it's kind of a little bit more complicated than just I'm going to make a mesh system or a graphic system or a renderer or a sprite renderer or something like that. The idea is that I'm building a framework so that any dev who wants to can make their own renderer, can make their own, they can make a system that like governs AI in a very specific, game-specific way, instead of having to work within the confines of whatever universal AI system I can imagine. And while I might provide, a basic 2D and 3D renderer out of the box, I don't want to lock folks into those. So for right now, I'm not actually creating a renderer or anything like that. I'm not even dealing with components all that much. I'm creating a entity system. I'm creating a way to register new component types and to register systems. And that's what I'm going to be trying to do this stream. So yeah, let me hop back over to, here we go, in Enterprise. So I kind of just, all I've got going right now, I may as well show how the build is set up to govern things. Right now I've got a little cube with Madeline spinning around. I basically just wanted to whip up something that I could test the window on in OBS because I wasn't 100% sure that it would display correctly. But to kind of provide an overview of how this works, let me open up the folder. There we go, Enterprise. So this is the folder that contains Enterprise. These three folders, I can actually delete those, but I'm not going to do that right now. Are just generation. You saw a little bit ago, I pulled up, I have a documentation that I'm working on, basically Doxygen takes and scans the comments in my code and creates a nice, a nice web-based documentation system that kind of like covers things, and I can actually like go in and write with Markdown, actually like do like nice, nice tutorials and whatever. But it'll also like give me, like if I go to the input class, I can actually see all of the API stuff for input. That stuff goes in docs, and then I've got an intermediate build folder, which is where all the pre-linked compilation stuff goes, and then the bin folder, which is where the builds wind up at the end. But basically, the enterprise project all lives in here. This is all of the engine stuff. And Sandbox is a temporary game project that I'm using to test things out. And as I showed in here, if I go back to sandbox.cpp, this is the entry point. So basically, you just start up, when you start up an enterprise project, folks will see something that looks like that, and it's just simple as everything. Most of the stuff you'll need is in enterprise.h. And then you basically will set up the systems that you need here. So you would tell the scene system which calls to make sure that all of the systems are updated and serviced regularly. You would do global things like if you're in a single player PC game and you don't actually do anything complicated with controller management, you might do something like I've done here, where you just say, all right, let's just make every controller the player one controller as soon as they pick it up and try to use it. And then you push your first state or series of states onto the system. And I say series of states because the State Manager actually maintains a stack of states. So you can do things like, if you've ever played like Kingdom Hearts, how in Kingdom Hearts you got this action adventure layer where you're in a fight and you got, you're controlling Sora and he's running around the scene, but then you got a little menu down on the corner that you operate like any other menu, to select your attack or whatever. Then it might open up a sub menu or whatever. And a state stack is meant to like allow for complex situations like that, where you want to have code that manages the 3D game or the scene, and then you also want to manage a menu, but you don't want to be doing that all in the same place of code. So basically, you just make a state for the gameplay, or the 3D gameplay, a state for the first menu, and then when you need to open up another menu, you just push another state on the top. And then from there, your states will drive everything else. They will, the bottommost state will probably, in almost all cases, be the one that actually renders the game scene, and it'll do that in its draw call. If you implement a draw call, you would do something like SceneManager draw scene, and actually I've already got the prototypes for all these functions set up, even though I haven't implemented them yet. And then like you would say draw scene and have it draw to a specific render target, and so on and so forth. And that way you can do, if you wanted to do like split screen multiplayer, you could do either four different states, or you could just do one big state and then just change the render target, and call draw scene 4 times. But yeah, so that's how that's gonna work. But anyway, hopping into SceneManager, or I think I had a train of thought and I just lost it. Did I have it? Did I forget to say something? I guess not. So basically, right now I've got a scene that's set up just for the purposes of testing things, and I'll probably clear this out later if I need it. But I had to set up a quick little renderer in here, and I'm like I mentioned before, a renderer is something that will be handled as a ECS system, so something that plugs into the SceneManager, and I just haven't done that yet because I still have to do SceneManager. So for here, I'm actually doing the low-level stuff, like defining my vertex attributes and stuff. But I've already got the graphics API going, so this stuff should be portable once I've got it in a renderer system. Anyway, taking a look at what I'm doing on SceneManager, the way that I like to design APIs is like I try and like work out everything in my head, and then I just do the header file for whatever system or what have you, and define the API in the header, and then just go through and start implementing stuff. So the first thing I'm going to be doing, and I've got a short list on my MacBook here, but I have to log in every time because my watch is broken and it's not unlocking on its own. Yeah, the first thing I was going to be looking at would be EntityID generation. That's something that's actually not going to be handled in the header at all. That's something I'm just going to do in here. So one of the primary pieces of an entity is that you have to be able to tell them apart, even if they are duplicates of each other. So if you are in a first-person shooter and you're shooting a whole bunch of bullets, every bullet needs to have a unique ID. But there's a couple of other concerns as well. So you've got every spawned entity, so things that are created by your game code, needs to have a unique ID. But eventually, there's going to be an editor, and eventually I'll need to have a way to craft scenes that can be preloaded from a file. And if I get some help, if I have like a teammate who's working on a game title with me, they need to be able to assign IDs to the entities created in the editor that don't conflict with mine. So that's handled by something called a UUID or a GUID, a globally unique identifier or a universally unique identifier. And the gist is that instead of just sequentially handing out numbers to each new ID, you generate a really random number. So you use like a 64-bit integer, and you just pick one somewhere in that space. And while that might seem a little crazy if you're not initiated to the topic, this is actually a pretty common tactic. And the reason why it's so useful is because with a 64-bit number, or like on more secure pieces of software, 128-bit numbers, there's just so many numbers in there that it's practically impossible that you'll ever have a collision. It's not very likely at all that you would generate an ID on one workstation when editing a scene, and then you would have the same ID happen on the other. Now that said, collisions, still theoretically can happen, but you're talking about I think it's like, I don't know, it's well over a quintillion numbers. What's 2 to the power of? Let me go to. Totally not trying to do a computer science tutorial, but it's like 18 quintillion. Let's see here. Not 709 million, billion, trillion, 18 quintillion numbers. So it's a very low odds, astronomical low odds. It's and like literally astronomically low odds. Almost all the stars in the universe will burn out before you're likely to have a collision. But collisions happen sometimes on even on 64-bit numbers. I think Naughty Dog, when they're working on their in-house game engine, they use the hashing system for generating quasi-random numbers from strings, and it gets a little complicated. But they needed to have a 1-to-1 correlation between the hash, the random number, and the string. And with 32-bit hashes, they had like 4 collisions over the course of 8 years working on The Last of Us. And The Last of Us, I think that, and also Uncharted at the time. I can't really remember the story. It's like really low odds, but I theoretically need to have some protections in there. So what I've decided to do, because there's going to be entities that are created in the editor when you're making a scene, there's going to be entities created in the game live. I decided to kind of partition the number space. So I've decided that the first n numbers, and it'd be just some number like 10,000 or 30,000 or however many entities I may theoretically maximally create in-game. Those are going to be handed out sequentially to entities that are spawned by the game code. So when you're creating a bullet, you're not getting a random number, you're getting the next available number in this space, like so 0 through 10,000 or something. And then when you're working in the editor, the rest of the number space is free game. And then that'll use random numbers. And the reason why I'm doing it this way is because I like to have my cake and eat it too. When you're working in an editor and you've got like a scene file, I'm pulling up a mock-up that I've been working on for helping work out serialization questions I had. But like say I have somebody is working on a scene file, and scene files are usually handled in text, and we'll come back to that in a little bit. But say I'm working on a scene file and I create an entity 1, 2, 3, 4, 5, 6. And then somebody else comes in and they make an entity 1, 2, 3, and just like by a random chance, they're handed the same ID for it, 1, 2, 3, 4, 5, 6. If we're working on the same scene file and we go to merge it in source control, we would theoretically pick up on the problem there. So when we go to merge, whoever is doing the merge might notice that, hey, it's instead of adding 2 of this line, it's just giving 1, and it's doing something like this, where it's got 2 names and 2 layers and things for the single entity. somebody would be able to pick up on that and correct it. And I think probably the editor will have some fail-safes in there to detect things like that, so developers will know. But if you're playing a game and you have a collision happen just by random chance, and if you got a bunch of players playing your game, it suddenly becomes a lot less unlikely. It's not very likely still, but it becomes possible for a system to generate the same UUID twice, and instead of having to deal with all the advanced mathematics of making sure that you're avoiding the birthday problem or avoiding issues with the way that you generate random numbers. I've decided that I'm just going to take and hand out entity IDs that are created at runtime sequentially, and then just make sure that I do that in a smart way, so that way it's not like spending every time you generate an ID, not looking for an available ID. I want to make that an order of one operation or a big O one, just so that you ask for an entity ID and it just hands you the next one, kind of like a stack pointer or something like that. But yeah, let's go ahead and start there. The need for a random ID is a ways off, so I'm not even going to bother with that right now. Basically, eventually I'll be creating a editor build of this, and right now I've just got builds that are just the game. But I think my plan, and I haven't really decided on the details of this, but I think eventually there's going to be an editor build where you build the game, and then it's like an editor that allows you to place entities with your components defined by your custom systems. And then when I get to that point, I'll need to generate random IDs. But for the moment, I'm just going to have sequential IDs. If I go back to SceneManager, I've got these two constant values, and the way that I do constants that are game specific is I literally just make them externs in the engine library, and then when at linking time, it'll link up to whatever values the game developer has set in some CPP file in their game project. So in this case, I've got max entities, which is the total number of allowed entities in the scene. I'm just picking 30,000 for now just because. And then you've got max spawnable entities, which are the sequentially assigned IDs. So in this case, just for the sake of demonstration, I picked 5,000. Entities 1 through 5,000 will be handed out sequentially, and then 5,001 through 18 quintillion, whatever, those IDs will be handed out randomly when you're working in the editor and designing a scene. I need some coffee. Give me one second. I've got a French press with a single cup serving in it, and it has made my life great. So basically, I'm just going to create a simple function to hand out each of these sequentially until they're all used. I mean, if they're hitting a maximum of 5,000, then wow, that's a lot. But a game dev could theoretically just tweak this number to make sure that they have plenty of IDs left to go. These are things that are going to be game specific. So hopping back into SceneManager, I'm just going to create it within this class. I'm just going to make a static EntityID. It's going to return EntityID, which is a type def. Oh, it's actually, I got to do SceneManager EntityID, and then I would say gen spawn ID. All right, and then let's see here. Did I not? Oh, I use State Manager. I'm tired. SceneManager, EntityID. And an EntityID, as you can see in this tooltip, or maybe I have to make it bigger. I don't know. If anybody complains when watching the VOD, I'll know to zoom in on my text. But it's just a type def for a uint 64t, so it's just a 64-bit integer. And then in order to hand out these things sequentially until I reach the cap, one way to do that would be to just like have like a counter, and I'm starting with 1 because I want to leave 0 as a reserved value. So if you pass an entity ID of 0, that represents a null entity. So we're starting with 1. But you could theoretically just do something like that, count, and then you would return it. And so you'd be like, unit, oops, I didn't put T on hand. I'm kind of new to live coding, so this is going to be a little bit rusty for me to be able to talk and code at the same time. But you could just like make like a value that you count, and then you'd say count plus plus to increment it, and then return the out int, and then that would be each time you call it would be return 1, 2, 3, 4, 5, 6, and whatever. And that's great. You can. Oh, thanks, Big Shark. I got a follower all of a sudden. That's cool. I'm not promoting this this stream to anybody at all, so it's kind of interesting to have people join. But yeah, you could do it like this. The problem is that you would eventually run out of IDs, and so it's not instead of If I was just doing the entire number space from 1 through 18 quintillion, then that would be no problem. But I'm not. I'm using a small subset of it. So even if you're never going to have 50,000 spawned entities at one time, you can't just keep handing them out sequentially, or else as you delete entities in the initial range, as you delete entities that you spawned, you'll have openings lower in the number range that you're not using. So what I think I'm going to do on this is I'm going to do a static. I'm going to do a container of some kind. I'll probably just do a vector of, and I know that it's literally just the uint64t, but I would like to. I'm using the type def to maintain readability, so I'm using a vector of entity IDs, and then this will just be a list of available IDs. And that might seem like a bit of a waste, because what I'm doing here is going to be allocating essentially a vector of every single available ID. But there's a reason why I'm doing that. It's because that's not a huge memory cost, and games built in this engine are probably not going to be very memory intensive to begin with. Where's my constants at? Yeah, 5,000. There we go. But I want to reduce the complexity of assigning an ID at runtime. And in computer science, there's a thing called big O notation, and I'm not like some kind of expert. I mentioned at the very beginning that I self-taught everything. But the idea of big O notation is that you are describing how complex an operation is given a set of data. So I don't want to be checking every number from 1 through 5,000 to see which one hasn't been assigned to an entity yet. I just want to be able to address a spot in memory that has an available ID for me, and then take it. 1 second. Ooh, my voice gets really raw when I talk for a long time. So what I'm going to do is I'm going to simply allocate a vector of all the IDs, and then when I need to get an ID, I will just look at the back. I will take that and use it, and then I will pop the back. And then as I delete entities over the course of the runtime from the spawnable range, I will add them back to the pool of available IDs by pushing them onto the end of the vector. And that will make it it'll make it pretty straightforward to get and maintain the list. So when you create or you delete an entity, it's an order of one operation to access the end of that list. No ID is ever wasted because as soon as the ID is free, it's just pushed back on the end of the vector. And then all the SceneManager, all the scene file IDs, the ones that are in the upper range, they're just completely unaffected by this. So I get to have my cake and eat it too. I get to have a nice source control for the entity IDs created in the editor, and I have an order of one lookup for getting an ID on a single instance of the game running. And I have a guarantee that there will never ever be a collision across any of the computers running the game. Which, you know, it was already low odds, but I'm kind of a nitpicker for that. I'd like to have my cake and eat it too. I'll say that a lot, probably. So I've got a vector of IDs. I'll say this will be available spawned IDs, and I do want to give it a size. So I'm gonna pull up CPP reference because I always forget the proper way for doing things like this. In general, when I want to do a fixed size array, I would just do an array. The problem with that approach here is that the value by which I'm going to be setting is not known at compile time. It's known at linking time because it's defined as a constant in a separate translation unit in a separate project. So what I'll do is I'll create a vector, and I'll just, when it goes to be allocated prior to the main function, it'll just look up that value and allocate it then. So yeah, vector, go to constructor, I think it's size, explicit size. So I think, yeah, you can just provide it a size in parentheses, and that's literally it. Vector words 3, yeah, just provide a value. So I would say available spawned IDs, and then I would do constants. What do I have to do? Oh, do I actually have to do enterprise constants? I guess I do for this case. Constants is the namespace in which I put all my constants in, and all of that's in the enterprise namespace. This is all kind of hacked together a little bit. At some point I'll have to go back and refactor and make it a little bit more readable. Or not, it depends on how much time I have. And then I can do max spawnable entities. Now, even though I'm starting with the number 1 and going through from 1 through 5,000, so the IDs are including the last ID, 0 is never going to be in this list, so I don't need to do spawnable IDs plus 1. I just need to do spawnable entities, and that should be it. So now I've got a vector that is the size of the available entity spawn space, which is, I think, let me do a quick back of the envelope calculation, which is, that would be 64-bit numbers are 8 bytes long, and you've got, in this case, 5,000, and that's probably more than I'll need for any game that I make. And then, sorry, that's quantity and size. Yeah, so divided by 124. Yeah, it's 39 megabytes is what I've allocated there. It's small fish. And then I need to populate this vector with all of the numbers. So this isn't a lot of. I wouldn't want to do this kind of code during update or whatever. And this is a paradigm I'm going to refer back to. I call them core calls, where you might recognize these from like Unity scripts, where you've got init, update, fixed update, and so on. These are kind of like an organizational device that I've adopted, so that when I'm working on a system or a state or whatever, I'm like, okay, well, I want to do something at the start of the lifetime of this class or whatever. So I just look for its init function and I add it there. So from here, what I'm going to do is I'm going to need to do a for loop. So for you know, I'm going to do size t because technically the type of addressable memory or something in arrays, I think, is like a size t. It's just a 64-bit int. But I'm going to say size t I equals 0. I is less than, that's not it, constants, max spawnable entities, and then I plus plus. There we go. And then I is going to be the index in which to access these, but I'm not going to be using it that way. I'm going to be using available spawn IDs dot pushback, or I should do dot in placeback because I want to construct them in place in memory. So I'll do in placeback for I plus 1, and that will go through every available ID from 1 through 5,000 and push them back into this array. So after the scene manager is initialized, we'll have a list of available IDs, and I can grab an ID just by selecting available spawn IDs dot back. Ooh, I'm letting my coffee get cold. I've been talking so much. All right, so now we've got that. When I go to gen spawn EntityID, it's actually going to be really simple. I'm just going to say EntityID, or I should say SceneManager. I'm not really sure I like having to call SceneManager EntityID all the time. I guess I don't in the functions that are actually properties of the SceneManager class. I don't have to do SceneManager EntityID, but here I do because this is just the local function. But I've got a return val that's going to be equal to available spawn IDs dot back, and then I would say available spawn IDs dot pop back, and that will just take that value off the end of the vector. And because of the way vectors work, that memory address is still there, so that, you know, later on when I go to push the value back to the end of the vector, it's not like reallocating or anything like that. It's going to just be pushing it back into the same address that I just left it, and then I can return val. Sweet, and that's it. That's literally all it takes to get a spawn ID. Now there's going to be a reciprocal function that I'll go ahead and do now, and actually it would be static void. I don't need anything from this, but it would be to actually I'm not sure that I need to wrap this in a function. I'm not going to wrap it in a function. When I'm done with an ID, like if somebody calls to delete. Calls a function that would delete an entity, I'm just going to have in the code in here, I would just say available spawn IDs dot pushback and or in placeback, and push the value back onto the stack then. In fact, this is small enough that I probably don't need a wrapper. I know that I will need a much more complicated version of this for scene files when I get to that point. So I think I'll hold off on that for now. Yeah, so let's go to the entity creation function. I've put in blank definitions for the most part here in the SceneManager.cpp. So even though you've got the prototypes, you don't really have what's going on in them. When you go to create an entity from game code, so if you're in a game state and you want to spawn something like the player character or something like that, you would start by creating the entity and then you attach the components after the fact. So the new entity would take a position and rotation. I need to have a place to store those, and I haven't created it yet. I think, yeah, when I was brainstorming, I got this prototype for the things I would need in an entity. So actually, I'm going to just take all that and put it in the CPP file. I don't think I have any reason to expose that in the header. If I if I do, then I'll come back to that and do it there. My style tends to be that I will, when I'm programming something, I'll keep as many of the details hidden from a header file as I can. And this is actually one of the reasons why I do static classes for my systems, is because unlike a namespace, I can make private members. At least I'm pretty sure namespaces don't have anything like that. I'm not an expert. And then I can have stuff that is not available to the game developer when they're accessing the system, but available to other systems. So for example, the application class manages the lifetime of an application. So this is actually where is this the header? Oh, this is the header. Okay, to open up the other. But like this is actually where all the systems get updated. So like when an application is created, it does time init, file init, input init, and all the other system inits. But by making it a friend class and by putting these in private, application can access it, but the developer who's making their game, they're not going to accidentally be able to call SceneManager init out of turn. They just won't see this pop up in their IntelliSense, and it's a protected member. So whenever I can, I just try to keep things as like static or global in the CPP file, so that way they're not exposed to the developer down the road, because I might not be the only person who ever uses this code. So let's go back up to what was I doing? Yeah, that's right. I was. Here we go. SceneManager. So I think what I'll do is I'll just define the entity struct here. I don't actually have any reason to be passing around an entire entity struct throughout the engine. Like the only thing that a developer will care about when they create entities is this number. They can pass that around, and that's the handle to the entity. And then like later, if they need to, there'll be helper functions for getting important details. So for example, if you're getting the position of an entity, you would call the get entity position. And that'll allow me to do cool things like nesting entities, where if you have an entity and you wanted to get its position, but its position is defined as a function of the parent entity's position, then I can just like handle that in the getter and do that. So this is just going to be, for my purposes, a way to store the data relative to an entity, and then I'll make like a static array containing it. So just to make this work, I need to do SceneManager, EntityID, and math. At present, I have my own little math library, which is I'm going to scrap it at some point. But when I was working on the graphics engine, I just kind of like threw in the formulas for doing things like vectors and matrices and projection matrices and things, instead of doing the obvious thing, which is to get GLM or get a math library in here. It's on my to-do list to actually go in and like integrate GLM and start using GLM stuff instead of my stuff, because the way that I'm going to be doing my first 2D renderers, I'm going to be doing a lot of batch rendering, and that's going to require a whole bunch of transformations on the CPU, which means that I'm doing a whole bunch of vector and matrix math on the CPU, and that's something that I don't want to do naively. I want to be able to use like SIMD and stuff, and I don't really want to take the time to program that. So this is eventually going to be GLM, but for now I've got to use enterprise and math. Well, hey, Big Shark. Yeah, I'm not really paying too much attention to the chat, so sorry, that might have been in the chat for a while. Yeah, the STD namespace, I get that this is like a matter of fierce debate, but I really don't like using namespace STD. So yeah, what Big Shark in the chat just asked was, why don't I just do this at the start of my files using namespace STD? And the value there is that instead of having to do std vector when I'm doing using something from the standard library, I could just do oops, I hit the wrong keys. I could just do vector, and then that'll just work because everything in the std namespace is now moved into the global namespace. I really don't like doing that, and it might be a matter of perspective. Like, I mean, like I get that you could see this both ways, because technically, yeah, it is bloating your code a little bit to put std all over the place. But I think it's really important when you're reading code that you understand where a thing has come from, and I don't see any value in obfuscating that at all. And by obfuscating, I do mean that it becomes less clear when you using namespace std, because if you using namespace std, what if you're working on a code base that they defined their own version of vector? Like if I was using EASTL, for example, EASTL, if you're not familiar, is a library that EA puts out on GitHub, I think. I'm going to pull that up real quick because it's actually really cool, and I think I might use it myself. GitHub, EASTL, here it is. The electronic art standard template library. This is like implementations of like a whole bunch of standard template library stuff that's designed to be like highly performant for games. So like they'll literally have versions of, I haven't actually used this library yet myself, so I'm not exactly clear on all the things that they got, but I'm pretty sure that they got things like, yeah, like all these things that would be in the std namespace normally. So like, what if I was using EASTL and I followed the same rule and I said, okay, using namespace EASTL, then somebody reads the code, they see vector, they think, oh, they must be using std vector, and they just don't know that I'm using EASTL vector, and they make the wrong assumptions about how it works and what it needs. So yeah, I prefer to keep things clear like that. So yeah, I don't know. It's a little political, the opinion, but that's long story short why I don't do that. I prefer to just use std vector, and then that way when I'm doing things like autocomplete things, you know, in here, I don't see things that are in the std namespace that I don't intend to use, and vice versa. When I go to use something in the std namespace, I'll only see things in the std namespace, and it makes my life just that much easier, and my life easier down the road. Yeah, that was a little bit long-winded, but hopefully that kind of answers that question, because that's a question that I've seen people field a lot. Anyway, where were we? So yeah, I just defined a struct here in this CPP file that's going to represent my entities, and now I want it to be what did I get here? Static assertion failed. I'm not really sure what that is. I'll come back to it later. So I wanted to make a static array, and I don't think I have the ability to do a array on just a straight array here, because this is determined at link time, not compile time. I'm a little fuzzy on that, but because I'm not seeing any red underline, but I'll leave that go for a second. But the gist is that I'll just have a fixed length array. Oh yeah, there's the underline. That must be followed by. Oh, that's why, because I'm not in the enterprise namespace right here. This might be one where I want to redo my thinking. So far, what I've been doing is I'm just not. Whenever I'm working in a CPP file, I just go and do SceneManager, whatever, and then like I'll using enterprise SceneManager to do it. And inside of each of these functions, I don't have to do enterprise all the time. But for this one, I'm probably going to be working outside. Yeah, you know what? Let me just do that. I'm going to do namespace enterprise. And go down at the bottom. There we go. And then I'll just, anytime that I see enterprise in this document, except for the first one, yeah, I'll just replace it with nothing. Yeah, good, and then I'll go back to the first one and re-add it using Enterprise SceneManager. Or actually, I can get rid of that too and just put this all in the namespace. Yeah, for the other systems I've developed, I haven't really needed to do that, to say using namespace. Do I have to do namespace qualified name is required? Oh, I do actually have to do. Yeah, I'll just put that down there underneath the globals and say using Enterprise names SceneManager. I haven't needed to do this in most of my systems because almost all the code for those systems were within the definitions for something in the enterprise namespace. But I think for this file, I'll just do a namespace enterprise and then be able to deal with that. But anyway, here's the wording I was looking at. Cannot use this as a constant. And the reason is because this, even though it's marked const size t, it is an extern, and that's actually defined in a separate translation unit. So I actually need to do something besides this. I don't think I can do std array here. I think I do have to do something dynamic. Can I do std array? Yeah, maybe Big Shark or somebody would know the answer off the top of their head, but I don't, because I don't often use std array. I like to use C style stuff whenever I can. But can I construct? Is that constructed at runtime? Where's the implicitly declared initializes the array using the rules of aggregate initialization? No, I can't. That's gonna have to be something else. So I guess what I'll do here, and I don't really like using std vector, but you know, some cases like this, it's handy. Right, I do std vector of entity. In some cases, it's handy like this. Entities, and then that should be all I need, right? Yeah. This is yelling at me for some other reason. EntityID. Yeah, for something like this, like even though technically, yeah, this is allocating on the heap, because when global initialization happens during the lifetime of the application, towards the start of the lifetime of the app, before a main function is even called, this is constructed, but it's not constructed. Like vectors are never constructed, their contents at least are never constructed on the stack. They always do it on the heap, so technically it does a little search for memory. But this is happening at the very beginning of the application. It only happens once, and it's, yeah, so I don't care. I can use a vector here. And then what I'll do is just not use it like a vector, I just use it like an array. Here we go, name. And the reason why I'm doing, by the way, the reason why I'm doing a size definition here is so that way it is already the size of all of the potential entities I might spawn. And that's because I'm doing that so that way as I add more entities to the scene, I never have to see it reallocate during runtime. It's just already got the maximum, and I'll probably have assertions guard against adding more than the maximum anyway, so yeah, that'll just ensure that it never reallocates. Though now that I'm saying that, how big is entity? Because no, you know what? I don't need to second guess myself like that. That's probably an acceptable amount of memory for the maximum entities. And then on a per game basis, the developer can come in and say, okay, when stress testing, I have only a maximum of like 10,000 IDs or something. For now, I'll just leave it at 30,000 because why not? Let me take a sip here real quick. Man, my throat gets really raw when I talk. I'm not used to talking this long in long spans. Why is this yelling at me? Must be followed by a class or namespace name. Oh, because I'm not in the enterprise namespace here. Alright. Cool. Well, you know what? I want... Yeah. I want the static stuff to be outside of the namespace. Because I don't want this to be in the namespace, even if I have to type enterprise for it. I'm having to make the code look a little more elegant. I'm going to have to rethink how I do this at some point, but not today. Anyway, so we got the entities. The stuff that I've added here is the ID for the entity itself. And I also need a way to address its parent and children. I'm actually going to comment that out for the moment. The idea is that when you're building a scene, you can place an entity and then put an entity as a child of that entity, and then just manipulate them all as a group. And that's something that you keep during runtime as well. And then I'll eventually need a way to identify the children. So I'll probably use a set for that because it's going to be one-to-one. There's the whole point of the identity ID is that it's unique, so there's only going to ever be one, and then I can organize it like that. And I'll hold off on tags for the moment as well. A tagging system is going to be relevant for categorizing entities, and if you've ever worked in a game engine before, you'll be familiar with that. I do want the position and rotation though. So right now I'm just kind of dealing with a simple, dumbed down version of the entity, and I'm leaving these commented out just so that I remember that I decided that I was going to keep them as I go to implement the rest. So now I've got a position and a rotation, and when I go to the new entity section here, I need to actually add one to the pool. So what do we got here? We've got vector of entities, entity indices. Actually, I don't need entity indices. I think that was something that I had thought I would need before. The entity indices is where you provide a... well, you know what? Do I? I guess I do. I don't know. Like, I could just do... There's a couple of ways I could do this. I could do this, which was what I was thinking when I was brainstorming, where if I'm wanting to look up a specific entity using its ID, I would provide the entity ID into a hash map. So I would just put in the number, and then that would return me the index into the array. I think why that's not so. I could do it like that. Before I wasn't using an STD vector for it. I was using just like a plain C array, so that would have made sense. But if I'm going C++ anyway, what I could just do is I could just take and make this an STD map, and then do an entity ID. What is it? State manager. I can type today. State manager, entity ID, and then use the entity ID to look up the SceneManager. I don't know why I keep typing state manager for everything today. But I could just use that to look up the entity, and then when I go to iterate over the list of entities, I would just like use a regular iterator. But part of the problem is that with doing it that way is that that's always on the heap, I believe, the way that it allocates. So you can't like pre-allocate the memory the way that you can with a vector. So the vector, when I'm setting this up, I say entities, and I actually provide the initial size of the vector. So I can make sure that it never has to reallocate the entire vector at runtime. What I'll do here... Yeah, I think it's not very elegant, but I just kind of want to get this done. What I'm going to do is I'm going to have the vector where it's just a front to back list of all the entities in the scene, and then I'll separately maintain a list here where I can directly address the the element in the vector for a specific ID. So I will keep that. Anyway, so in the new entity section, I'm going to do entities.pushback. I'm going to do in place back because I'm actually going to construct it right here. And then I'm going to define a entity. So first element of the entity struct is the ID, and I'm going to get that by using gen spawned entity ID. The second element for the moment is position and then rotation. So I can actually just grab those from the parameters being passed. So position and then rotation. And then bam. So we've got the entity placed in the back. Is there a problem? Matches the argument list. Std vector entity. Oh, I don't have a... Huh. I feel like I've overlooked something obvious here, but it's looking like it's inferring my list as a object type is vector entity. Is there a problem with in place back? Huh. Okay, so pushback works. But I thought in place back would work because this is constructed. This is itself constructing an entity. What if I did? I think the default constructor for entity would handle this, right? I think the default constructor exists for. No, I would have to define that constructor. Okay, whatever, I'll just do pushback, it's no big deal. And maybe when I'm reviewing this before merging it with source control, I can decide whether I want to keep that. So anyway, I've got the entity in the pool now. If I go to, I need to add the index to the ID now. I'm going to do entity indices, place, or not push, what? Oh, it's a map. Right, I'm being really tired. So the index here for, or the key here is going to be entities dot back dot ID, and then I'm going to set that equal to entities dot size -1. So that way I'm getting the size is going to be the number of elements in, and the last element is going to be the one I just pushed in. So now I've got the entity and I've got the entity indices. And that's it for the moment. I've constructed the entity. Even with the stuff that I've forecasted here with the parent, children, and tags, this is the stuff I expect that I'll be adding to the entity eventually. You'll notice that I don't actually have any mention of components in here. That's on purpose. Because of the way that I'm going to be doing component systems in the engine, those are going to be defined on a per system basis anyway. So the systems themselves will be able to govern, first of all, how those are allocated, and what data goes into those, which in most cases I would, recommend doing a plain old data struct of the things that you need in the component and then just doing a C-style array if you can. But that's going to be up to the developer. But to get the details of one of those, so like to get data from a component, all you need is the entity ID. So what you do is you just call, I think I've got a prototype in here as well for get, or I might not have yet, but I'll eventually do a like a get data or get component data function, and then you provide the hash name of the component and that you're wanting to get data from and the ID, and then that'll call a callback for the functions. And we're not quite into setting up those callbacks yet, but that'll become clear as we go. Okay, so we've got entities being added to the pool, and then I may as well just implement the get entity position here. So what that would be entities, and that would be, well, I guess first I should have checked whether the entity exists for the ID. So for these, I'll be doing probably not an assertion because I don't want this to be a fail condition, but I'll do if def ev config debug, or may do if in def dist. So if we're in, I've got 3 different build configurations for the engine. There's debug, dev, and dist. Dist is the shipping copy. Debug is the just like every other debug, where you got no optimizations turned on, and all of your warnings and errors and assertions are available. And then dev is where optimizations are turned on, but there's some debug controls left. So like assertions that are on infrequent code paths are still turned on and things like that. But I'm just going to do a warning to the dev out the console if entity doesn't exist. So what I'm going to do is I'm going to do EP if ndef EP config dist, and I'll say if TIDs or indices dot count of entity. So this, what this does is it checks to see how many elements are of this ID are in this map, and that's either only going that's going to be 0 or 1 because you can only have 1 of each in an SD map. But that's I'm going to leave that to say if that's false, or to be a little more explicit, I'll do equal 0. So if there is no entity by that name, I'll say EP trace or EP error. This is my for the moment, and this is going to change too. For the moment, this is the logging macro I have for logging at the debug console. So I'll do EP error, SceneManager, get entity position. And this is something that I got. It's yet another thing on the mile-long to-do list I have, is to make it so I don't have to like spell out where I'm calling this from every time. But for the moment, I'm just gonna do it. Entity. And I'm putting it in error. I have 5 different logging levels. Error is the second most severe. I'm doing it as an error because this is a bad condition, but it's also not one where it'll break the game. I don't want to cause the game to have to restart whenever somebody uses this improperly. So what I would do here is return 0. And vec3s have an overload where I can just return an integer, and it'll just turn it into a vec3 with 3 zeros in it. But outside of this one condition that I'm checking, I just return maybe entity indices. Entity, and then I would plug that into this isn't actually very elegant. I'm not very happy with this whole two container situation. But I'm just going to leave it for the moment. Dot ID. Or dot position, sorry. Cool. And then I just duplicate all that for the rotation and redo rotation instead. And rotation is roll, pitch, and yaw in degrees, but is represented here as a vec3 as well, so I can just do return 0 on that and it'll work the same. All right, cool. And then that would be that. I guess I'm trying to remember what I had to do on my list next. I did a quick, before starting the stream, I did a quick list of things that I wanted to get done in the order that I wanted to do them. I think I'm probably going to deviate from that real quick. I'm just going to go through some of the definitions that I haven't made. Well, first let me just make sure this compiles, because I haven't done that for a while. I'm pretty sure it will be fine, but because we didn't really do anything really extraordinary yet. But just double checking. Yeah, and I've got the register functions. These are actually implemented already. The gist is that when you add a system to the simulation, you'd say register fixed update function to do a fixed update. And then all of a sudden it'll start to be called every fixed time step. Yeah, so I did overlook something. Where's that? Enterprise, new entity. Oh my god! I never returned a value. So created a new entity, but I actually do need to return. Yeah, this is why you check your work. Return entities back and ID. So that way, when you go to create a new entity, you actually get the handle back. Yeah. Yeah. Sorry, I don't know how long ago you asked this question, Zorn. I'm actually surprised that there's even anybody watching the stream. I didn't advertise it at all. But yeah, why? For anybody watching on video on demand, he just asked. Maybe a silly question, but why not just use EntityID as the key for the entity lookup? That was something I was thinking about doing before. There's 2 reasons I can think of right now, and I might change my mind about this later, to be clear. I'm kind of hacking this together, and I'm not like a professional game dev or whatever. But the first reason is that I wanted to be able to pre-allocate the total array of the total array of entities, and that was where did I put it? Here. So I know that I'm going to have a preset maximum. So when a developer goes to create a game, they'll define for themselves the maximum number of entities they want in their simulation. And I can't pre-allocate, at least I don't think I can pre-allocate an STD map with that, with the, 30,000 or however many entities you want in the scene. And then the second is that I will probably be, well, actually the second reason I had is probably not a valid reason. I was thinking in my head that by keeping it in a contiguous array that I could just iterate through them all real quick whenever I have to do that. But now that I'm thinking about it, I'm realizing that I don't actually have to do that. Because the way that I'm doing the components is that the components are managed separately in their own pools by their systems. So each system can manage its own allocation of their components. And when you're updating the simulation, when you're every frame when the world state needs to increment, that's going to be handled pretty much on the component side. All of the data in all of the components needs to be updated. But you're not regularly updating the position and stuff directly from the entity because it doesn't have any behaviors. So I don't know. The pre-allocation thing is the main thing that I'm thinking of, because I want to be able to not have to reallocate or allocate on the heap for every new entity you create. But for the moment, this is how I'm having to do it. Because if I want to be able to do that, I need to be able to define a container that has that number of entities in it. And I'm not aware of a way to use the SCD map or a hash map to pre-allocate all of the entities I need. So I'm just going to do the more lightweight. I don't know. The more I talk about it, the less sure I am. But this is one of those things that I think I'll review later and decide, because this is actually not a lot of data now that I'm thinking about it. So it might not be a huge deal to have this stuff be allocated, have this entire struct be allocated every time you spawn an entity. But like the C programmer in me wants to do everything, do all the allocation at once and not have to allocate again later. But the problem with that theory is that I'm having to do on the heap allocation here, even though it's just for one number. Yeah, I'm going to leave it like it is for now and come back to it later. Yeah, you're right about that. Optimizing the lookup is kind of the big deal, but heap allocation is probably a bigger deal for me right now, because almost all of the logic that's going to be going on for entities is going to be going on with the components, not with the entity struct by itself. So like, it's not going to be like you're going to be dereferencing an entity ID to get the position from your game code very often. It'll just be like something that you do for a handful of component types. So I might come back to that later and change my mind. I often do that. But anyway, per spawn entities and per scene entities. I'm not going to bother with those for the moment. I'll go and comment those out in the... Well, I might as well just leave them and leave them empty. This is something that I'll deal with later. The idea is that in gameplay, you might just want to say, okay, I need to clear the scene of all the spawn stuff and then start from scratch. And I have a line between these because the scene entities and the spawn entities kind of have different pools, and it would make a lot of sense for you to want to clear one but not the other. So if you're loading up a new scene and you want to get rid of all of the stuff from the previous scene, you would say purge scene entities and then add the entities from your next scene. But then you don't want to get rid of like all the player characters and enemies or whatever. So you would do that separately. I don't know. I'll leave that there for the moment. And then what was next on my list? Yeah, I guess we're at the point where we're dealing with component registration. So this is one that I spent a lot of time prior to the stream thinking about how to do it. And it's not great, but here's what I came up with. Towards the start of the stream, I was talking about how the overall design is to be where I don't actually prescribe any component systems to the developer. The developer has the ability to just make their own and then plug it in to the SceneManager, and then just have their new components and their new systems work with the entities. So you can just make a component that does whatever niche thing you want your game to do. But I'm kind of balancing the goals of making it powerful and simple, and that's kind of hard to do. One of the objectives of making things simple is not just to make it easy to read. It is to minimize the possibility that you're going to make mistakes as a developer. And so I kind of came up with this solution where if you make a system and you want to register a component type, there's a number of things you need. You need, first of all, you need a function or a callback that SceneManager can use to add your components to an entity. So it'll tell you that, okay, we're loading a scene that says that it wants one of your entities. I want this entity and I want it attached to this entity ID, or a component to an entity ID. It also needs one to delete it. You need to be able to query which entities have a specific component attached. You need to be able to access the data from a component given a specific entity ID. And then the trickiest part is that you also need a way to serialize it. So if you're editing a scene in the editor, and that's a ways off, but eventually I'll have an editor for this. if you're working in the scene editor and you place a component of this new type on an entity, you need to be able to save that to the file. And because the system is in charge of all that, it has to tell Enterprise, tell the engine how to do that. So you need a serialized function and a deserialized function. But it gets worse because you also need a binary version of both of those for when you're no longer working with text files. So I couldn't really think of a more elegant solution than simply making those all parameters of the same call. And the reason why I'm doing it as the same call is so that way you don't have to remember a whole bunch of different registration calls when you're creating a new component type. You don't have to say, SceneManager, register add component function and register delete component function, because it's easy to forget one of those. But also so that everything is in the same place. The text serialization and binary serialization, realistically, when your game is going to ship, you're going to only be using binary serialization. So, like, in some sense, like, I was thinking about, like, maybe I would if-def these and say that if you're in a debug build, you would only have text serialization, and if you're in a disk build, you only have binary serialization. But I decided just to include both because worst case scenario is that even if you make a game that never uses text serialization in the finished product, the cost of adding another pointer to a array of function pointers is minimal because it's just something that you do at launch and you never have to deal with again. So I just decided to just make like make one function, one mega function that takes all these pointers. And I might change my mind about it later, like everything I've talked about today. But in order to make it kind of somewhat readable, I've got all these function type defs to make it a little bit easier to tell what you're doing. I'm not going to do the serialization stuff right now. And the main reason for that, as you can see by the red underlines, is that first, I don't have a YAML library loaded. And I don't have a binary file reader or writer set up yet. In my file system, that would be that's not it. Control T file.h. Yeah. I do actually have a low-level system that lets you do reading and writing to text files, and eventually I'll have it so that you can do reading and writing to binary files. But I haven't done that yet. And for YAML, I decided that I wanted to do scenes in YAML format. This is a mock-up of one that I've been working on, so I can kind of tell what I'm looking for when I go to create a scene file. I don't want to write my own YAML serializer, so I'm probably just going to grab. There's a library I had my eye on GitHub for doing C++ YAML stuff. So I think I'm actually going to comment that stuff out for the moment, just for the sake of getting this done. But I need to do register component type for all of the others. So I need to do a hash name, and I don't think I've actually covered hash names on the stream. And I'm not trying to do like an overview of Enterprise while I'm on the stream. I'm just kind of decided to work on the stream, and then later I'll do a whole YouTube thing where I actually like explain how the engine works. But a hash name is just basically you plug in a string and it gives you a hash for it, and I use those. And there's some string interning going on, so that way you can check for collisions, and then if you're in debug situations, you can get the actual string back for the hash. But I'm going to be using hash names to identify the component type down the road, so the editor and stuff can track which component type it is. So you got to provide the name of the component, or the hash name of the component. There's a Boolean for whether you're adding into adjacent scenes, and that's something I don't want to talk about right now. So I think I'm going to comment that out too. I'm just going to comment out all the good stuff. But the things that we need to worry about up front are add component, delete component, query component, and get component data. Those are kind of the fundamentals. So let me review the prototypes for these kinds of functions up here. Make sure that I've not overlooked anything. So if you're adding a component, you want to have you may want to have a bool return to tell whether that was successful. I'll just leave that for the moment. The entity system will be telling the callback which ID it is, so we take the entity ID. I think that's probably all we need. It's occurring to me now that I would also need a way to initialize the data in the components. So maybe there will be a callback for that. But on the other hand, the data, for now, I'll just leave it so that the entity component data is unchanged. So it's just these zeros up front, and then the system can initialize to whatever default values. I'll worry about initialization later. A delete component function doesn't need to return anything because it's either going to be successful deleting it or it didn't exist in the first place. And then this index, I think that's probably the way I want to do it. I have the entity ID for the entity that you want to delete the component from, but it's also possible that you would have a system or a component system that would want to allow multiple components of the same kind attached to an entity. And if that were the case, you may want to be able to delete specific components from it. The use case for this is probably pretty niche. It would be like if you constructed a component directly from your game code, or just constructed an entity from your game code, and then wanted to individually manage the opponents. I think I don't know. Maybe somebody else has some thoughts about that. But I was thinking that maybe when you go to add the component, it the system can push back in a sense, it'd be all associative, but it would associate a second component to the same identity or same entity ID. And then when you go to call delete function, you know what? I think the delete component function should always delete all the components of a type from an entity. I'm just going to make that call right now. I don't find it very likely there will be a situation where you'd want to delete one of a component and not the others from the component. So I think I'm just going to leave it as the entity ID. So that way you just say, this is the entity that I want to delete all of this component from. And then vector, type-def vector, query component function. Yeah, this one is interesting. The query component function just means that the SceneManager asks the system, give me a list of the entity IDs that have this component on it. That's helpful in a number of situations where, for gameplay reasons, you want to treat the component as a tag. So for example, if you're trying to create a save file in a real-time game of some kind, and you want to serialize all of the entities that have an AI associated with it, you could tag all of those enemy entities with like a serializable or an AI tag using entity tags. But instead of having to go through all that, you could just use a property that they all share anyway, which is that they have an AI component on them. So this would be just a way to get that list. And I think returning a vector is probably a good enough way to do it. And then get component data. This one is I like C stuff. I like working directly with like raw pointers and things myself, but for the sake of making an elegant API, I might change this around a little bit. But the idea is that you ask for No, I'm not doing indices anyway. Oh, I do need to do indices. Oh, that's something. The idea is that you query SceneManager and say, okay, I want to get the data from this component from this entity, and then it'll just call the callback registered by the system and return a pointer to that data. I got rid of the index up here for the delete function. I think I'm going to need to keep it for this function, because if you have a system that has multiple, or that allows multiple components of the same type per entity, then you need a way to be able to get them. So I think I'm going to leave that. And so basically, what if you're trying to get data from multiple components at the same time, you would do like a for loop, and then you would say, like if maybe I'll have it so that this returns a null pointer if the index and entity didn't provide a component, and then you could just do like while the get component data function doesn't equal null pointer, then you can cast the pointer to the component type. And any system that's having to look up data this way, they'll have the header for the system that governs it, so they can cast to the correct kind of struct if that system uses structs. So I think that's probably fine. That's probably where I want it. Cool. All right. So all that's left is to implement this basic stuff now, and then we'll worry about serialization later. So that means, where did you go? Component type. I changed the definition, so when I go to control click on the one in the header, it's not pulling me to the correct location. Oh, you know what? It was commented out to begin with. That's right. So I actually had to go and create it. So I'm just gonna use the refactor, and yeah. All right, and then that's been defined. Register component type here. Except for that should probably be above the others. Yeah, let's do. Well, it is above the other API calls, but not above getSpawnedID, which, yeah, you know, it's organizationally it makes more sense to be for ESpawnedID to be declared / defined directly above the functions that might use it. All right, cool. So now we've got this thing. We got the name, the add component function, the delete component function, and so on. So when we go to register the component type, what do we need? We need a table for each of these, I guess, or the ability to look up for each of these. So I guess that'll be a hash table probably. So hash table look up by the name, and you can get each of these. So let's go ahead and define those. I'll do STD map, and we'll do hash name will be the lookup key for the component name, and then we'll do add component function, and that's defined within the SceneManager. So I'll do SceneManager add component function. And then I'll do ACFs. This is not public facing, so these can be a little bit silly names. Then I'll do one for each of these others. Delete component, query component, and get component data. ECS, query component functions, and get component data. I don't know. I didn't put an F on the end of get component data function because I don't know. I'm neurotic, and I like the idea of having all of the names have 3 letters. I don't know. Don't know if that helps its readability. When people are looking at like the quick help, so when they're like looking at the IntelliSense, they'll my impression is that their primary takeaway will be that, okay, this is the add component function, this is the delete component function, looking at the type instead of the function name. Because the alternative would be that I do add component function, then like add component function again, and that's like redundant, and just makes it wordier than it needs to be. All right, so I've got a map for looking up each of these, and so pushing these into the lookup table is actually pretty simple. We'll just do ACF's name equals ACF, and we'll do the same thing for these others. Basically, we'll do DCF, QCF, and get component data, and then okay, cool. And now we've got the component name, and we've got all of the functions that we might need for handling the component data for the moment. Okay. And this is probably going to get more, well, probably, it's definitely going to get more complicated after we're dealing with serialization and stuff like that. But yeah, basically, when you go to make your system that needs a component type, we just call this thing, we give it right away, we get all the callbacks that are needed for the component. And if you mess up one, that would break the whole system, and so I depend upon it failing to compile to alert the dev to say, hey, you didn't register the component correctly. Cool, so it's a single point of failure for a single problem. Cool, so now we've got the register component function in there. We want to take a look at now how the components work. So when the components need to be serviced, that's going to be handled by the systems themselves. This is something that was just simple enough to do, so I did it before getting on stream. I have callbacks set up already for, here it is, for fixed update and update. So this engine uses a variable frame rate, of course, but it also has fixed time step updates. So the idea is that this is called once every frame, at least right now. Right now I'm doing single-threaded everything, and eventually I might do a separate rendering thread, but for now, this is something that's called once every frame, before every frame draw. This is something that's called once every fixed time step. And the way that single threading works is that that's actually just once every time step on average. So at the start of each frame, we'll see how much time has passed, and however many fixed updates should have occurred since then, we call fixed update that number of times. But these are the only two recurring calls that components need, or component systems need. And you might think that's weird because, like, what if you make a renderable component? But that's actually not handled here. That's actually handled in draw scene. Because the way that I have it set up is that when you're setting up your game states, so you're saying, okay, we're going to do the main menu now, or we're going to do gameplay now, or we're going to do split screen gameplay now. The state that you program to manage the current state of the game, that will be what actually calls the draw scene function. So you can call draw scene any number of times. And then for rendering purposes, there's an additional reason why I separate draw scene from the regular draw call, and that is because you might need to draw the scene multiple times with different shaders before you composite and you produce the final image. So a trivial example of that would be like if you were like how in Smash Bros, I think it's like a Pokemon Stadium level in Smash Bros, where you got the TV monitor in the back, the Jumbotron, that shows what's happening on the stage. Like in order to or like in Portal, where you can see through the portal to the scene on the other side of the portal. In order to do stuff like that, you need to be able to render the scene more than once per draw. So a renderer that can handle like portals might do a thing where it sets up the camera transform and everything in the shaders, so that way it's ready to draw the scene that's through the portal. And then once it's set up everything to make that happen, and it's got the render target for whatever frame buffer that will actually hold the image that you will put on the portal on the wall, it would call draw scene then. And then after that's done, take the contents of that frame buffer, put it on a texture on the portal on the wall, and then call draw scene again, and then just draw the scene with that texture on it, or what have you. So there's many reasons why this should be divorced from the regular draw call. So the scene's not actually drawn automatically. That's something that you choose to do in the state, ultimately, and then each scene system during draw scene may recursively call it. So I think that's the basics. Are we at the point now where we got to deal with serialization? Yeah, I'm not going to implement these quite yet, because actually the way that I've decided to do scene loading, I think I probably don't need to purge scene entities anyway. I'll have to explain why at some other point later, but it'll take some time to do that. Yeah, so I think at this point we've got all the basics for this, because component registration or component management is actually not handled here. It's handled by the systems themselves, and they just register the callbacks using register component type. So yeah, I think I'm going to take a break for now, and then when we come back, I'll be looking at adding a YAML serialization library, and then setting up serialization. And I've never used this library before, and I've never serialized in YAML before, and I've only just barely learned how YAML works. So this will be kind of probably a rocky period. But yeah, let me take a break. I'm gonna maybe brew some more coffee or find something else to soothe my gravelly voice, and see you later. Boop. Alrighty, I'm back. My tea hasn't quite finished brewing yet, and I've got some oatmeal, which is going to be my breakfast. It's even though it's kind of a late breakfast, it's on Pacific time, so it's 11:30 almost where I'm at. So I hope people don't mind that I take a bite to eat every now and then. But yeah, where we left off, we had set up component registration callback, or component registration callbacks, the function for that ECS systems will call to say, hey, I want you to handle my component type. We need to now consider serialization. That's actually going to require a little bit more work. Let me make sure what we did compiles. I didn't do that before the break. And then I'll take a look at how to handle. Come on. I'll take a look at how to handle YAML after that. Okay, yeah, it's building. And this for people who are just tuning in, this cube, spinning cube with Madeline from Celeste has nothing to do with what we're doing. I just needed to have something graphical to test out OBS, to make sure that OBS was capturing my game properly. I've never streamed before, so I had to check myself for a lot of these things. Anyway, there is a C++ YAML library that I guess everybody uses, and it looks pretty simple, and I think I'm probably going to use it. Is this the one? Yeah, I think it's the one. Let me double check. Yeah, where you just like have an object for the node or an object for the writer, and you just do the bit shift left, the two arrows to output to it. Even though I'm not seeing it right now. This is the one, I'm pretty sure it's the one. YAML nodes where they, if I'm just seeing SDDC out, people, maybe I have to do how to emit YAML. That's where they go over it. Yeah, so basically you've got YAML emitters for, which is like an object that you'll use for outputting the YAML, and you just take and use the standard bit shift left operator for outputting whatever values you want. And I'm not really using these streams to like do like tutorials or anything like that. But the gist of what I'm doing for anybody who's totally lost is that I need a way to be able to save scenes to files. And one of the complicated pieces of that is that if because of the way that I'm structuring the entity component system, all of the systems that can introduce their own components, most of which, probably almost all of which, in a practical game will be developed by the developer, because that's a way for them to add behaviors that's data oriented. All of those systems that are custom need to be able to serialize into the scene file also, which means I can't prescribe the way that the data goes out. And I wanted to kind of make it as abstract as possible, as I wanted to make it so that that each system has total flexibility, but I also don't want to make it too hard. And I think that using this YAML emitter is probably the way to go. So the idea is that, and I'll go back to SceneManager. Here, I got these registration functions, and I'll go to the header because it's got the prototypes of the functions. So I'll do Control KU to uncomment those. The idea is that when you go to register a component type, one of the things that you'll provide is the serialization and the deserialization function. It's important to actually do a text serialization function for the sake of game design. Probably the first primary reason why you'd want to do that is for source control. It's actually really easy to just dump out to do a binary dump of your data. I mean, like you can, fuss about how you structure it or whatever, but ultimately you just take whatever's in your structs or your array of structs or whatever, and you just push it out to a file in binary. That's actually pretty straightforward to do. That would be the easiest way to serialize and deserialize the entities in the scene. But if you take that extra step and convert it into text to make it like human readable like this, then that has benefits for working on a team, because if you're working on a sizable project at all, you're not going to be doing this by yourself. You would have multiple folks working on scenes that are checked into a version control system. In version control systems, by and large, work best with text files. So Git is the most popular one, obviously. Like this is the YAML library I'm looking at is on GitHub, for example, and so is my engine library for example. So like this is all checked into GitHub. But there are others, but they all work very well with text. So that if somebody makes a change to this file, and then separately I make a change to this file, and we've got two different versions of the file now, we just plug it into source control, and source control will identify what changed in both and say, okay, so here's the change that this person made, here's the change that this person made. Do you want to keep them both or whatever? And that makes it really easy to reconcile differences. So if you're in a situation where you've got two people working on the same scene file in the same editor at the same time, you want to be able to not throw away work. You want to be able to take the work that somebody did on the same file. AC is getting me. You can't really hear it on the microphone, I'm sure, but like the way that my apartment is set up, like I got like resonant nodes and anti-nodes where the AC unit is just kind of really loud, and right in this room it gets kind of resonant with the AC unit, so I had to close the door. Where was I? Yeah, so if you're merging work from one person working on the same scene file as you, then it gets kind of hard to merge them in a binary file. So a text file is kind of critical. And I went with YAML because it's really easy on the eyes. It's not very complicated to understand and parse. Like you don't have. I mean, you can, but you don't have to have curly braces around everything. You can just do lists and stuff, and it tends to be it's something that for a while I will be editing scenes by hand before I get an actual editor that will automate that, where you're actually designing a scene with a GUI. So I'm going to be working in text for a while. I want it to be a little bit easier on me. And YAML is like a very popular choice for this. And so there's some weird libraries out there. Unity scenes themselves use a version of YAML, I found in my research. Though I've decided to do it a different way than they do. Like if you go to YAML scene format, there's actually a part of the documentation that covers how the YAML scenes are constructed, and here's an example of one. YAML has like a document separation structure. We have these three little dashes indicate the start of a YAML document. And Unity has like this thing where like each one of these is a object in the scene, or something like that. So you have this is a simple example, but like you have a document, a YAML document that handles each game object and each component. So like the transform components each have their own. And that gets kind of, it's not very easy on the eyes for me. Apparently it works quite well because Unity still uses it. I just kind of organized it in a way that organized my YAML in a way that seems easy enough for me to understand. So there's only a couple of things that I'll need. I'm imagining that eventually I'll need to have, and this is full of stuff that I'm not going to be implementing for a while. I just wanted to like make sure that I future-proofed the format. Eventually I'll need to have details about the scene in order to track what's changed. So for example, if somebody's working on a version of the enterprise library that's slightly older than mine, and they try to open up a scene file that I made, they'll at least want to know that there's a difference between the build that they have and what I've got. And that actually matters quite a lot more in an enterprise game because, like I keep saying, the systems themselves and the types of components that are available are by and large game specific. So I may provide a renderer 2D or renderer 3D out of the box, but it's not implemented out of the box. You can choose to add them to the scene system or SceneManager or not. So if you're working on a 2D game that has no need for 3D graphics, you're not stuck with the overhead of running a 3D renderer pipeline and setting it up and so on and so forth. You just don't include it in the game init setup function. So those kinds of details will need to be saved here. I think I'll probably just do a scene key which contains scene data, and that'll tell us like what version of the game you need to be able to work on this, because different versions of the game may have different definitions of components, so that's kind of important. And then which systems are needed to be hooked up. So this is something that probably will be important for transplanting scenes between game titles, because there's going to be a couple of run-of-the-mill systems that I'll include out of the box. By including a render required systems list, it'll prevent problems like where you try to open up a scene file from one game and another game, and they don't happen to have the same systems, and so they can't all read the same component data. So this stuff I'm not going to be dealing with today, but eventually you'll need it. Adjacent scenes is a thing that I was working on last night to try and identify how level streaming might work. And there's a complicated system that, well, it's not hugely complicated, but it's, as far as I'm aware, nobody's done it this way before, so it would require some explaining to do, but this is stuff that has to do with streaming scenes, entities from other scenes, if you're trying to do like an open world game or something. And then here's the stuff that we care about today. There's the entity and component keys. So like in YAML, you can have a key, it's pretty much always key value pairs, and the value can be additional keys or whatever. So the way that I'm going to be doing it is I'm going to be doing a key for entities and a key for components, and then just like everything that's relevant to the entities, going back to here. So like this data is serialized within the entities section. And then the components section is kind of a free form section where the component systems can choose what to insert. So this is just some dummy examples. I mean, obviously, I haven't built the parser yet. But for example, if you had a sprite system, and I put a comment here. If you had if you did renderer 2D might have multiple kinds of components, and I'm expecting that a 2D renderer would want to have like fixed sprites, things that don't change, that are just part of like the environment or whatever. Animated sprites like characters or anything that has like a sprite sheet that needs to be updated over time, and then the ability to render text, and that's complicated, but that's something that a renderer would do. When you register a component type, let me go back to this guy. When you go to register a component type, you're passing a pointer to a, I haven't implemented yet. You're passing a pointer to a text serialize, a text deserialize, a binary serialize, and a binary deserialize function. And binary is basically just the binary equivalent of the text serialize and deserialize. But my plan is that when you go to register and you provide that pointer to the register component, the scene manager now knows that when it is told to serialize a scene, it can call upon the system to serialize the components that it wants. So basically it'll, when we go to serialize the scene or a portion of the scene, it will first create the YAML file or insert into it if the file already exists, and the scene manager itself will handle the entities and the scene and all the rest of this stuff by itself. And then after that, it will ask each system to add its data to the components section. Each component type has to have a unique name, which I didn't assert, did I? I'm thinking about it. I probably should assert that. I need to make sure that when a person goes to use register component type, that the name has not been used before. So I'll probably do that as an actual assert. I'll deal with that in a minute. But these are all unique, so they could just be used as keys. So a system, basically, after a serialization call is made and the scene manager is ready to serialize the components, it actually just like stops here. It's got the stuff that it needs for the scene and for the entities themselves, the ID and their names, their layer, and all that other stuff. But then it starts the component node and then doesn't add things. It then sequentially will call each system to serialize its components there. And then the way that I'm probably going to do it for the out-of-the-box systems is that I'll have them serialize by providing the name of the component type, and then having a list of nodes containing the data for each of those. So each component would be serialized with like its associated EntityID and any of the other raw data that it needs to work correctly. And then after that's done, it just returns, and then we're back in the component node, and the next component system can push its stuff in. So, I've divided these up. Technically, they don't have to look like this, but as long as the system outputs what it needs and can read what it needs from the same node, then we're good. So what I need to do now is I need to get a YAML serializer library going on in here. And that means that I'm going to need to step out of the engine for a minute and go into the build system. So Enterprise, and if you're just tuning in, that's the name of the game engine. Enterprise uses pre-make to build its project files and stuff. That's how I build on Mac OS, because this game engine also works on Mac OS. Give me a second. So I literally just keep a copy of pre-make 5 in the version control, and then I have a script that you just run pre-make for Mac or Windows. It makes project files. So to add a library, what I like to do, and I've done this for a number of libraries now, what I like to do is I like to add them as Git submodules. And I tend to keep them here in the enterprise project underneath the vendor folder. And then that way, if there are updates to the libraries and I want to take part in them, I just go into the submodule. Like this one is a Hot Constants is a library that actually I made that I include to do on the fly reloading of certain values. I could just come into here and then git bash and then like check to see if there's any updates. Just git fetch and then just update it and then update the main repository once I've got the updates. So coming back to the library that I want to use, it does not. How to build? It uses CMake. So I actually do not know how to use CMake. I barely know how to use Premake. I'm going to say this again, that I'm not a professional programmer. I'm self-taught, and I never worked a developer job. So CMake is one of those that like every C++ programmer should know how to do. I just haven't done it yet. I'm going to take a look at its build file real quick, and I think I can probably just, here we go, CMake lists.txt. I might be able to just call the CMake script from my Premake file. And then that way when I go to build, it automatically generates the YAML project. So I guess the first thing to do would be to add it as a submodule. And I always forget how you do this because I don't do it very often. Get add submodule. Yeah, so it would be just get submodule add. All right, so let me go back to the main folder because this has to be done in here, enterprise. I'll go to git bash, and then I'll say, maybe I should make that text a little bit bigger for the stream. Then I would say git add submodule, and then path, shift insert to add path. And I should also provide the path to where I want to store it. Because I don't want this in the root directory, I want this in the vendor directory of the enterprise project. I know this is like a very common sentiment among programmers, but I would be nothing without Google. Let me take a bite of that oatmeal that I've been staring at for 20 minutes. Alright. Yeah, so it's like, okay, yeah, remote URL and then the destination folder. So I would then just do enterprise vendor, I think. Yeah, vendor. And it will automatically create the YAML folder, I think. Will it? Yeah, I think it, or well, I'll just do one of my own. YAML CPP, I think is what it was called. YAML-CPP. And bam. Path submodule did not. Oh, is that, I messed up somewhere. It would be get submodule add. Yeah, that's what I messed up. Get submodule add. Okay, cloning it, and now I should have warning line feed will be replaced by character return line feed. That's fine. So now I've got, if I go back into enterprise, I go to enterprise, go to the vendor, I now have the YAML CBP section. So now I've got to find a way to add this to my build process, so that way when I go to generate the solution, it'll add the dependency here. It'll add. I think I'm actually showing folders, so if I refresh, then it'll actually show the folder. Yeah, but it's not enough to have it here. I need to have it producing its own library and linking correctly. So let me go back to how to build. See, make the build. See build. YAML CBP builds a static library by default. We want to build a shared library. Okay. So I guess that will automatically make the static library. And I can link it from there. I tell you what I'm going to do. I think that Cherno has got a video on how he did this. Cherno is a great resource for learning C++ stuff. C file. I think he used for his game engine Hazel. I think he used it, and I happen to know that he uses Premake because he's the one who introduced me to.
Heads up, guys! My name is Chano. Welcome back to.
Hopefully, I don't get like copyright infringement just for looking up his video while on stream. Runtime. I'm sure he's got. Oh, maybe it was here. Wait, was this the video I just opened? Oh my god. All right. I think it was. Oh, yeah. Here we go. So this is. So I saw he had YAML on the video. Okay, so yeah, he's adding it here, and be interested to know how he does it. Yeah. I think what I'll do, because like I like to refer to developer videos for like tutorials on how to do things, and I don't want to get a copyright strike. Not that he'd be the person who would copyright strike me. So what I think I'm going to do is I'm going to put the stream on break. I'm going to take a little bit of time off the camera to sort this out, and then come back after I've gotten what I need. All right. Alrighty, yeah, I'm back. Yeah, I was reviewing the. I found the spot where the Cherno had done this before, and what he had done is he actually made a branch of YAML CPP that contains a pre-make file, and I don't think I want to clone his branch. I might, but I'm looking at it now, and I think I may just want to add the pre-make file myself. Because this is, if that's all it takes, then I can just take it and copy and paste this, or do something similar. He doesn't build for Mac, which I do, so I'll have to refer to my own. But yeah, he just does a project kind of C++. I'm also using C++ 17, so that could be the same. Yeah, I guess it might be that simple. Maybe I can just copy over a pre-make file from my own project. The way that pre-make works is that I don't know how similar it is to CMake, but you just do you do workspace for your solution. I have a group for dependencies, so that way within the solution you can see the dependencies or dependent projects. And then you can link them in here. I've started by putting the linking over to a Lua file that contains the pre-make for the YAML static library project, which I'm going to be making in a minute. And I have a link set up to that project. So what will happen is that this dependency it'll produce a project in here. If you go to dependencies, it'll actually produce a project in here which will compile into a static library when I go to build, and then it automatically figures out the pathing and links to it using the name that is provided in the, I think it's provided in the pre-make library file. So I think that's good for my solution side. I've got the includes and I've got the linking, and I've got the project dependency. So I'll just save that, close it, and then go to enterprise vendor YAML CPP. And I guess this is where I would include the pre-make file, and I just want to make sure that there wasn't any other setup that Cherno did on his. So I'm comparing the folders and files just to do a quick smell test to make sure that everything is the same. Code docs, good ignore. That's obviously not part of it. Travis build.basil. I guess I had that too. I don't know what that is. But I'm sure it's part of the original. CMake contributing license, brand name, workspace. Netfair.yaml, installs.txt, yaml config, .cmake. Yeah, it kind of looks like everything is here. The only thing that's that the Cherno added to the root directory, at least, was the premake5.lua. And if we take a look at its contents, yeah, all it does is it tells you where to build and stuff like that. So yeah, I guess I instead of basing this off of his, I should base this off of one of mine, because I have my own pre-make files that I've made for my other libraries. So I'm just gonna copy and paste. This is the pre-make file I use for building my hot constants static library, and I'll just base it off of that because it's got everything in set up for this solution. YAML CPP. I guess we'll just do it here. That would be Control Shift N. Oh no, that's a new window. I'll just try not try and be smart, and then I'll just right click and do it that way. So I think I named these pmlibrary.lua. technically, Premake will search first for a file named like premake5.lua or something, and then it'll it'll be premake5.lua, and then use it. But I have actually defined a separate name for the Premake files for building libraries, just to make it a little bit more organized for me, so that way when I see premake5.lua, I know it's the one in the root directory and it's the one for the overall solution. You lose your voice really quickly when you're talking by yourself on a stream. Go back to the one I just made. I'm going to paste in the contents of the PM library.lua from hot constants. And I'm going to say this is YAML CPP library premake script. And this is instructions that I put into the premake library file from that's actually like in the repository for hot constants. So I actually don't need that. That's not helpful in this case. So configuration name, platform static 6432. I don't actually need the 32-bit architecture. Like, this is going to go unused. Enterprise is straight 64-bit. So what'll happen is that when I go to link, it will, in the solution side, it'll actually only build this one. So the configurations only will reference the 64-bit. But I might as well leave this in here just in case it would be helpful. Configurations debug release. I don't see any reason why I should make this different. I don't really remember why I required 1015 on hot constants. There was a reason, but I don't think it's important. I might as well just leave it. I have a 10.15 requirement, I think, for the way that I'm doing the game controllers on Mac. So I'll have to leave it like that. And I'm actually fighting the impulse to require Big Sur and later to do macOS 11 and up, because as it is with ever since Catalina came out on macOS, you're disallowed from reading raw mouse and keyboard input. So like when you go to try to read just like the raw mouse delta, like subpixel resolution from the mouse, you'll get a little pop-up that'll say that the program is trying to track your input, and you need to give it security permission, like it's a keylogger app or whatever. And it's a pain in the butt, but if you like this is a thing that still affects like AAA games that were made back then. Like if you play on Catalina or later, like Borderlands or something, and I don't know why you would do that, but if you were playing Borderlands on your Mac that's running Catalina and later, you might see a little pop-up say, hey, this program wants special permissions to get your mouse input. And so because that's like a no bueno, I don't want that experience for people playing games in Enterprise on Catalina and later, I'm kind of limited right now to just using like window space stuff, so I can get the keystrokes but not actually like the key state information. So I have to like myself count every time a key gets pressed or released, and then handle edge cases like when somebody like command tabs out of the program. And the mouse input can't be high resolution, so it doesn't do high resolution mice very well, for example. But starting with Big Sur, they've added to the game controller framework, they've added the ability to get raw mouse and keyboard information. And that's great. That's something that I really want, but it would mean that if somebody wants to build a game for through Enterprise on Mac, they would have to target macOS 11 and later, and that's like that can be a turn off because there's a lot of folks, even like hardcore Mac fans, that are really hesitant to move on from OS 10. But yeah, I'll leave that requirement there for a moment. Didn't mean to go on a rant, but here we are on the other side of the rant. We'll leave symbols on for debug. We'll optimize for release. I think release is going to be used no matter what in my builds, but I'm not 100% on that. Static 64, static 32. Yeah, I just need to change the files. So this is going to be YAML. Wait, no, include. Let me go to the folder. So this is the YAML. So it's the include directory. It's got the YAML CPP. Yeah, and that's it. So I'll do YAML CPP, and then everything in here and everything in the subfolders that's got a .h on it is going to be included. And then the source files, helpfully, is also just a folder called source, and that'll do nicely. It's actually got Is that how I have it set up? Because it looks like there's also .h files in their source folder. Which is a little unusual. Generally, you'll have a division there when you're making a library. I don't know if that's going to cause a problem. I think it will, because when it goes to build, the CPP files will be referring to H files that are not in the include folder. So yeah, I've got to add another folder here. Okay, and that folder is going to be source **.h, and it'll be every .h file in the source folder. Okay. And it's always worth double checking this sort of thing because they might have things that you'll forget. Like sometimes you'll have HPP files in your include folder instead of H. What's in this markdown file? MSVC debugger visualizer for... Oh, okay, that's something I don't care about. Cool. And that should be that. That's the include. And I need... I don't think... Yeah, this one doesn't have a precompiled header, does it? Do I actually have a precompiled header for hot constants? I guess I do. Yeah, precompiled header. So yeah, I'm gonna take a look at the way the journal has it set up. He does not reference a precompiled header, so it kind of sounds to me like they don't use precompiled headers. Not a lot of libraries would. I just did in hot constants because I had a lot of standard include files to do, and it would take a while to rebuild because a lot of the header files. Yeah, so I'm gonna get rid of that. Don't need that section at all. So we got the files, we got the platform, which I'm just gonna leave it with what I did for hot constants. Configuration name, which is got the okay. Yeah, I think that's it. I think that's all I need. I'm gonna Control S, save that, and I think we're probably good. Let me save that and close out of Visual Studio. And moment of truth time, we're gonna see whether the Gen Premake will build correctly. So we've generated the YAML CPP project. We've now updated the enterprise project and the sandbox project, because the sandbox project needed to be updated to include the YAML includes, in case the devs want to use the YAML output or YAML reader for their own purposes. Okay. And if we go to Enterprise, we go to Dependencies, there's the YAML project. And if I go to Properties, yeah, it's building in the bin folder for Windows 64-bit and for the YAML folder. So that's just another organizational thing I do. In Visual Studio has this weird way of organizing the builds when you build out of the box. I prefer to have it just all in one folder. In this case, I would have the intermediate folder. I haven't built anything yet, that's why I don't see it. But yeah, in here, it'll probably. Oh, it doesn't actually do it here. It would do it. Does it do it in bin at all? I might be confusing myself. How does Hong Kong do it? Yeah, so actually it would be building within the folder. So the bin and binit are there. I guess the only other thing to worry about would be to make sure that I'm not including the build folders in my source control. Let me go back to git ignore, and yeah, so actually I've already taken care of that. I just have it globally skipping folders that are named bin and binit in my git ignore, so that's good. And let's go back to, did I make a change here that I didn't save? Yeah, I didn't say that. All right, and then go back to here, and hopefully it'll just, F5, it'll just build correctly out of the box. Yeah, building YAML cpp.vcproj failed. So let's take a look at the error list. Cannot open include file. Okay, so there's something wrong with how I'm including my stuff. Binary.cpp. Yeah, it's YAML source binary.cpp. But I'm sure I got a clean format files, binary code base. Okay, whatever. Include LH. Huh. Oh, okay. So. Oh, you know what I think I did? Okay, let me go back to the pre-make file. I think what I did was I accidentally included includers. Yeah, that should just be include. In hot constants, I used /hot constants, so that way when I was programming in the hot constants headers, I'll go back to its source and double check this. Yeah, so I didn't actually want to do include hot constants / for every one, so I just made the contents of this directory be on the include path. It looks like YAML doesn't work that way, YAML CPP. So let me go back to it. I don't need to modify it, so I'll just control all my changes. I do need to rebuild though. And I technically could just leave Visual Studio open and let it handle that part for me, but I'm not interested in that. Sometimes it doesn't detect it, and maybe things go wrong, so I just close it and relaunch it. You go back to the scripts, pre-make Win32. All right, and it's done. The YAML project is the only one that needed to be changed. And open up the dev solution again. All right, so now F5, and hopefully that'll just be the end of it. No, I still got the cannot open include file errors. So let's open. Yeah, I know. Open one of those up. YAML cpp /dll.h. Yeah, no. Include. Huh. So apparently it's include the YAML CPP folder is in the include path, but dll.h is not. And looking at all these errors, it's actually just that file. This is the worst part of development, in my opinion, is setting up all of your build stuff. That's just never fun. It's great to have it, but it's you kind of want somebody else to do it for you, which actually might be what I might do in a little bit. If this winds up being a huge problem, I might just fork the journals who's already got pre-make set up. YAML CPP, include YAML. So I don't see a dll.h file in here. Is it present in the Chernos fork? Source, wait, including YAML CPP. Yeah, so he's got a DLL file in there. So is that built then with so I'm looking in the actual directory. Yeah, so dll.h is not present in the original. So I guess I can only suspect that this is created when you run CMake on the original project. And just to gut check me on that one, I'm going to go in and see if I can find. Is there just a way to search directly through the source code from here? I guess not. But if I go to CMake lists, dll.h, export file name, generate export header. Yeah, so there's some part of CMake set up to generate this header, and I don't really understand it. Like I don't know how CMake works, and I don't know what dll.h is supposed to be for. So I guess what I could do is, on the one hand, I could just copy and paste what Trino added to the source control for his fork, because apparently he generated it and then just added it to his fork. What I think I'll do instead, though, is I'll actually just run CMake. Should I do that? It seems like it might be a bad idea. If only in that it would leave a solution file in the source control. So if I build it using the cd build CMake, I'm assuming it would just come out in the root directory. Yeah, so it would theoretically just come out here, the .sln. I don't see one in the Chernos copy. And I'm not really familiar enough with CMake to be able to just figure out which command to not include. So that way it's not generating the solution file. That's only making, because I want pre-make to make the solution file. So I think I'm just going to go ahead and cave and just copy the generated file from the Chernos fork. That way I don't have to learn CMake or any of that stuff. I don't understand though, because this looks like it's a unique identifier. I suppose it's just a random number. This is a header guard, it looks like. If defined. Okay, the way that I'm interpreting this is that this stuff is actually not even used it's only ever used when you're compiling as a DLL. That's my impression, and I'm not doing that. I'm statically linking it. So yeah, okay, I'm just gonna go ahead and add the file to the header file. Include YAML CPP, and I'll do a new file. I'll call it dll.h, and then copy pasta, and thank you, Cherno, for doing all this work for me already. I'll save it, and then I actually do need to rebuild the solution. I'll just leave it open, so that way it'll add the dll.h to the project file. Scripts PM good, it's updated, and then there we go, reload all, and now the include should include dll.h. There it is. We'll close that out and F5, and fingers crossed that'll be the end of it. One downside to this, though, is that I've now made a modification to the now it's building. Okay, I've now made a modification to the I'm having a brain fart, to the submodule that I made of the library, and I'm not gonna make a official fork, because I think that's a little bit much for what I need. So I guess what'll happen if I go to source control. So there's the YAML CPP submodule that needs to be added. And inside of their dll.h appears. So I guess technically what I've got is I've got to add the submodule, and then the dll.h needs to be committed to that submodule, and okay, and that would be a problem, because if somebody was to clone my repository after that, using recursive submodules, which is how you get submodules out of how you get submodules from their original forks, they'll only get the one without dll.h. And I don't think that dll.h can be considered part of my Git repository for enterprise, because the Git repository inside of the vendor folder takes precedence for version control. Okay, so that's actually going to be a problem. I'm going to need to make a fork if I'm going to use it with the other. And I've never done that before, so yeah, I guess today's full of new things. So what I'll need to do then, I'll have to undo the change. So I've got Git modules and the submodule itself. I'll want to keep the pre-make file, but then I'm going to use Visual Studio to rewind the changes I made when I pulled in the submodule. So dll.h, I need to keep you. I'm just going to put it in a unsaved file. And then I need to keep the pre-make file. Yeah, there it is. Copy. And then I'll just paste you in a unsaved file as well. Okay. So I've got you two. And then I can leave the pre-make 5 from the root directory. That's not this file, but okay. So I can go to get modules, undo, and then I will discard the change for get modules. And I need that. And then all of the untracked changes here, I need to revert those. Yeah, and that's everything inside the EMLCBP directory. Yeah. Score changes. 48. Yeah, it's all right. Cool. And that's actually, that should be okay now. But what I need to do is actually delete the directory itself because it's got the .git folder for its version control. So if I go to enterprise and go to vendor, there's the LCBP. So now that that's all reverted, it's no longer part of, yeah, so I actually got to delete this now. And hopefully I'm not forgetting a step. Undoing a get submodule change seems like it might be prone to failure. Okay, and that should be it. Vendor, yeah, no longer have the submodule in there. I undid the change to the submodule file in here, which is, I forget where it is. So if I was to open with code again, yep. Yep. And there's the unsaved copies of those files that I'll need later. Go to Git, source control. We got hot constants, we got SPD log. We don't got, we don't have the YAML submodule. So yeah, I think that's everything successfully reversed. I don't need to, let me go back to pre-make 5. Yeah, so I've got the changes. I need to have these changes anyway in the pre-make 5.lua. And everything else is just the stuff I've been working on SceneManager. And these are temporary files that I'm not tracking at all. Like I've got things like temporary texture images. And, it's a little hard to see because this is actually pixel perfect, but that's the little sprite for Madeline. But yeah, that stuff can be untracked on purpose. Okay, all right. So now I need to make my fork. Another thing I'm new to. So I guess I would directly do that from here. I would say oh, here it is, fork. I'm gonna fork it to my GitHub, which is the other Michael. Okay, and then I'll have a repository that I can work on. And what I'll do is I'll get submodule on this fork and then make the changes that I wanted to, and then commit them and push them. And then that'll make it so that when you use get clone with recurse submodules, that you'll actually get the changes that we need to build YAML CPP. All right. We're back on track, even though this is taking way longer than it probably should. So I need to get the clone code. I need to go to the folder. I'm going to close this guy out for the moment. And then I'll go to git bash, what was it? Get submodule add. Then I paste the path, and then I do the destination, which is vendor, and then YAML CPP, I think is what it was. Oh wait, did I get, yeah, I got it, it says the other Michael. Okay, good. All right, my Git directory is found locally with remotes. Oh, did I mess something up? Looks like I did. It seems to think still, because I've deleted the folder now. We don't have the previous the previous script download, but apparently my Git version control still is tracking the original YAML CPP. Yeah. All right, this is fun. Let me open up the whole Git folder in code, and I'm just gonna search for YAML CPP, and I'm just gonna locate all of the submodule stuff. Config, the other submodule. Okay, so this is the submodule that was added when I did the change today. So that's left over, and it's complaining right now because it knows that the location here is identical to the one I just entered in here. So let me close let me go back to it. If you want to reuse this local Git directory instead of cloning again from, use the force option. If the local Git directory is not the correct repo. So that's all correct. What I'm going to do is I'm actually going to go in and clear out the changes that were made. So I'm not really sure what GUI is, but I'm sure it's fine. I'm sure that was there before. The trouble is that the actual stuff in the git folder is not part of version control, so I don't see any highlighting in Visual Studio Code that tells me exactly what was changed. I just kind of have to figure it out. Core, work tree. Okay, so this is part of the modules, enterprise, vendor, YAML CPP. I'll go back to the vendor folder. Reveal in File Explorer. Vendor. All right, so this is the YAML CPP that was saved here. I need to delete that. And I think we're in the clear. I think I finally got the cleaned up the mess that I made by doing a clone of the wrong repository. Because when I search YAML CPP now, that only comes up as a deleted file. Okay. And to save that. YAML CPP. Yeah, now there's no results found at all within the .get. So if I was to run this now, the same script as I ran before, the Git should not be confused about which. Yeah. So now it's cloning correctly from my repository, from the one that I just forked. Okay. All right. Let's go back to Enterprise. All right, so that's that. I should have under Enterprise vendor. I'm really tired. I tried to go to bed early last night, but I couldn't quite sleep, so I did the natural thing and played Mario Kart on my Switch until 3 a.m. CVP. So this is the repo that I need to modify now. If I go to git bash, git status, yeah, so it's linking up now to GitHub. All right, so now what did I need to do? I needed to add the pre-make file. Let me go back to code. Oh, did I mess up? I did. I think I got rid of the files I was leaving open in the unsaved state, which was, shame on me. But it's not that hard to fix. So let's go back into include. I needed to add the dll.h. Oops, that's a folder, not a file. I forget the Windows command for text file. So that's going to be dll.h. Yeah, I know. And then that needs to be filled up with that generated file that I don't want to bother generating myself. So I'll grab it from Journal's repository. Copy. And pasta. Yeah, that's okay. And save. So that's good now. And then I needed the pre-make file, which shouldn't take too long for me to build it again from my other example. We'll go to scripts or enterprise vendor hot constants, and it's this guy, pre-make library.lua. Copy, and then I'm going back into YAML CPP, pasting it, and then let's open this guy in code. I think after I've gotten the library added, I'm going to go ahead and terminate this stream because it's taken longer to get this going than I thought it would. Yeah, so what I could do is just do anytime hot constants is used, or hot constants, then I will just replace it with YAML CVP. Okay, and then I'll get rid of that. Needless description, update this to say YAML CVP library premix script. Not that it really needs an introduction here. Configuration, yep. YAML static lib C++17, yep. Latest system version. Oh, now I remember why I needed system version. It's because there's no equivalent for latest on the system version on macOS using pre-make. I have to actually specify one. So 1015 is what I picked. Yep, configuration, yep, static, and yep, and I needed to add the source/*.h because it has header files in there that you need, and I needed to get rid of that because the source files actually they actually all specify YAML-CPP, and I don't have any precompiled headers. All right, and then save it. That should be it. That's the pre-make file and the DLL file done. Let me gen the solution again and confirm that that works, and then I will commit that, post and push it to the fork, and then I should be good. Now you go back to enterprise scripts, pre-make. Okay. Actually, I should probably do the whole thing and delete it. Let me close out the Bennett docs and enterprise. And this is part of the reason why I love having all the generated stuff in one place, as I can just go and clear it out like in pretty much one go and not have to think too hard about it. Yeah, that should be that. And I haven't compiled the fork yet, so that I don't have to clear that. All right, go back to scripts, and we'll go to pre-make. And we got the solution, got enterprise. Okay, it didn't say that it generated the vendor. So did it do that last time and I forgot? Yeah, there it is, so that's fine. Cool, and yep. And go back to enterprise and open up the solution. And hopefully this will just all work out of the box, because I'm ready to do something else with my day. Yeah, it looks like it's building correctly. I should also check to make sure that the optimization and symbol flags are linking correctly to my configurations. I haven't checked that yet. Enterprise has got a stranger way of handling, a slightly different way of handling the build names. It's got, instead of debug and release, it's got debug, dev, and dist. And I don't know why I picked dist instead of release. I think it's probably just because everybody has a picture in their head of what release is, and I wanted to differentiate that from what you would like test a game in. I don't know. Probably not worth changing back right now, but okay. So it's building. We got mandolin spinning around. Let me go back to this guy. EML CPP includes source. So that seems to be working. But what I wanted to check was, I'm going to go back to debug, going to the configuration manager, and I wanted to see, so in debug, YAML is being put into, oh, you know, I'm kind of remembering now how this went. I think what I did is, because libraries don't tend to have dev and dist configurations, I think what I had done like years ago, or a year ago, or whenever I made the original, I think what I had done is that in my original pre-make file, I have it create those configurations for the other projects, and then just automatically map them such that they here we go. Configurations, dev, dist, optimize on. Yeah, so this is where I did it. So I'm actually ignoring the in the pre-make file for hot constants and for YAML CPP. I'm actually ignoring its builds. It by default has debug. And debug by default I think has oh no, it's pulling that from the original. Yeah, it's hard to keep this straight in your head. So it's pulling the debug build from the source file, and then here I'm saying that I also want a dev dev or dist build to have optimization turned on. And symbols are by default off in in a non-debug build. That's just the way that Premake handles it, I think. So that should be good. Yeah, so if I go back to here, even though the configuration manager doesn't, oops, go back to debug. Configuration manager doesn't tell me specifically that I am using the release build when I go to dist. If I was to go into dist build now and open up its project properties and go to its, I think it's underneath here, options, try to optimization. Yeah, so it's got optimizations for favoring speed and symbols. I forget where. Maybe symbols are in the linking stuff. Symbols. Or maybe it's not called symbols. I forget. But I trust that I correctly did it for the other libraries when I set it up before. I just want to go back to debug and check it now. I guess I can just change it up here. But if I go to debug and I go to all options and search for optimizations, optimization's disabled, and dev has got optimization as well. Eventually I'm going to do whole program optimization. I just haven't set that up in Premake yet. It's not really important to me right now. But cool, all right, so that's the library, and just to make sure that it's not gonna backfire on me, I'm gonna go ahead and do include YAML CPP, and I think it's just YAML.h, and confirm that it actually works. Yeah, it opens fine, but I'm just gonna do a quick test to make sure that it's correctly working. That would be YAML. So we include YAML.h, we create a YAML emitter, and then you would say out.cstring can output. So I'll just do a quick check in SceneManager. Well, let me do that in dev state actually, so it's not a problem if I forget to fix it. So include YAML CPP YAML.h. I will create a static YAML emitter, YAML out, and then you just use a bit shift operator to get it to be the output. So in it, I'll just say YAML out hello world, because that's the thing you say when you're doing things for the first time in programming for some reason. And then I can see out the output. So instead of see outing the output, I'll just do eb trace, which is the logging equivalent. I'm going to do YAML out dot cstring. All right, and now it should say hello world in YAML. There it is, client hello world. And of course, I didn't actually do any nodes or anything like that, but or anything complicated. But that's just showing that, yeah, it is compiling and linking correctly. We confirmed that it's optimizing when we are in this build. And on this one, because this library is tried and true, I may want to tell it to use to optimize in debug as well, but I'm on the fence about that because you never know if I might find like an edge situation where the parser doesn't work correctly, and I want to know exactly where in the source code it does that. So I think I'll leave it as is. But great, all right, that was a relatively productive day. I've got a lot of the basics of the SceneManager going. The hardest part of the day was just getting YAML CPP in there. I guess I should round this out by actually committing the changes to the fork, and then I guess I could commit just the modifications to put the YAML in the solution. So let me do that real quick. Close out of that and that. And I like to use Visual Studio Code for this because it's just whenever I'm doing git fetch and commit and push, I often just use the shell, the bash. But for this stuff where I'm managing a bunch of different changes at once, I like the GUI, and code has got a good one. All right, so let's go to open with code. I will need to, so go into source control for this file. Oh, you know what? I need to, there's one more thing. There's always one more thing to do. I need to actually do a git ignore file for this repository, because it's right now seeing all of these other files. Do I care though? I guess I won't, because I'm not likely to make more changes to this repository. So what I'm going to do is I'm just going to specifically commit the 2 files I added, and all of these things that it says that it sees as untracked changes. I'm just going to leave them there and not bother with a git ignore file to hide them. Because I'm not going to come back in here and do more stuff like that. So I've got the pre-make file, which allows me to build the thing in the first place, and the DLL file, which is normally generated by CMake, but I'm skipping because I'm using pre-make instead. All right, that would be cool. And those are changes to this sub-repository. And now that I've committed those changes, I need to push them so push, and that'll push it to the fork I made on GitHub, which should be showing up now. Your repositories. CVP, and we see one commit ahead, and that's the one I just did where I added pre-make library to Lua. All right, and then that's done. I can go back to the enterprise repository, this one, and open it with code. And then all I care about committing right now are the changes to the submodules. So those are already staged. And and then this modification just happened because I had just pushed a change and it tracked that. So it can see the second commit. All right. YAML CPP, and then I need remake 5.lua to include the YAML, and then there's a .diff file that's been generated. I'm not sure. I guess it might have been, I don't know, I'm not sure whether it was generated by Git or something or what, but I don't, actually I don't even see it. It should be, it says enterprise vendor. It's not here anymore, so it must have been a temporary file that's gone. It's actually empty still, so that's all right. Refresh to see if it's still there. And it's still showing up for some reason. That's all right. Cool, and then the rest of this is not part of it. Cool, and I'll say added YAML CPP build system. Cool. Nice. All right, and that's that. I think that's my day. I'm not gonna push on enterprise quite yet because I don't anticipate there being any problems, but I haven't really started using YAML yet. So if there's a problem, then I want to be able to reverse the change on my local repository. All right. So it was didn't advertise this stream at all. It was just kind of like a stream of consciousness sort of day programming live. But some folks popped in and had a couple of brief conversations, which was kind of cool. I think I'll continue to do this. I don't know how. I'll see how I feel about it the more I do it. I'm not really a streamer or a YouTuber or anything by trade. But yeah, I don't know. I'll see you when I see you.